Okay, so in this video, what I'm going to do is show you how to work a chi-square goodness of fit question to a uniform distribution that is in my stat lab. One of your classmates had sent me their response and asked me how you actually go about doing that in JUMP. So I'm sure you've recognized this question. If you used a template that I provided you, you don't actually have to use JUMP. But naturally, the goal here is to get the response out of JUMP quickly so we could pass judgment easily. So this is a question regarding high school level of education and how you receive food stamps. And they have some observed data here. So, not having high school had 33 people on food stamps. High school grads, 37 people on food stamps. And college had 28 on food stamps. And if you notice, it says at the 5% alpha level, can you reject the claim that the distribution is uniform? Now, naturally in JUMP, you would expect that you could just do this goodness of fit test to a uniform distribution really fast. Unfortunately, it's not so easy. It's not that it's not easy. It's just that, it would be nice if they had a menu set up for it already, and they don't. So let me show you how you typically would do a goodness of fit. I already put the table in here. So in other words, if I go back to the question, I created a new data table, and I called it no high school, college, and here's the frequencies. So typically what you would do is you would go to Analyze Distribution, and you would grab the frequencies and drag them into your Y columns. So let me go ahead and do that. And say OK. And it's going to create a histogram for me. So here's the histogram. Now, I don't like to view this vertically. I like to view it horizontally. So if you click the little red triangle and say stack, it just makes it more pleasing to look at. All right, so there it is. Now, if I click the red triangle on frequency, you'll see down here there are two fit scenarios. Continuous fit, so like if you wanted to fit to a normal or what have you. And then they have a discrete fit as well. Discrete fit, Poisson binomial, a couple other distributions we didn't talk about, gamma Poisson and beta binomial. But unfortunately, if you notice, there is no uniform option there. All right, so that would make you believe that that you can't do it. In fact, you can. They have this other method for doing it, but it would be really nice if they said uniform in there. All right, but it doesn't. So, it kind of hurts us there a little bit, but not terribly. So let me close this out and show you another way where we could kind of work around this. So I'm going to go back to my data table. I'm going to go back to Analyze Distribution. I'm going to grab the variable name, which is education, and I'll pop it in Y. And I'm going to grab the frequencies and put them in the frequency field and let it create a bar graph. All right, so there it is. And once again, I'm going to stack it because I like to look at it side by side. All right, so there it is. And if you go to the red triangle for the variable name education, notice there's this option called test probabilities. So I'm going to select that. All right, now look what it does. First of all, it shows me the frequency. College is 28, high school 37, no high school 33. I believe it orders these alphabetically, so you don't have a choice in that. The total was 98 frequencies, so 28 divided by 98 gave me this, about 29% there. 37 out of 98 and 33 out of 98. So now, if you want to test the probabilities, these are the estimated probabilities based on the observed frequencies. Now, if this in fact is uniform, that means each of these things, which there's 3 categories, that would mean that they're equally likely to occur, right? So that would mean that each one has a probability of a third. All right, so in the hypothesized probability, I'll put in 0.3333. It's not going to let you put in 1/3, so you have to type in, 0.333. Now, you might say, wait a second, you're just putting in 0.333, and, that doesn't add to 1. Yeah, I know, but it'll rescale it for us. Don't worry about that. And it says that down there. Fixed hypothesized values and rescale omitted. So it'll take care of that for me. So in other words, here's the observed percentages. Here's the hypothesized percentages, with an equal likely occurrence. So I'm going to say, okay, done. Now, what does it do for me? Well, it gives me, as you can see, the Pearson chi-square testing statistic, which is 1.2448. Tells me the degrees of freedom, which makes sense. Okay, there was 3 categories. You lose the degree of freedom. And there's the p-value, 0.5367. which tells me that's greater than any alpha we pick. So we will fail to reject the null hypothesis. So it appears that this data, in fact, is coming from a uniform distribution. So that Pearson 1.2448, it wants 3 decimals in MyMathLab. So I'm looking at this example that's in MyMathLab. That to be 1.245. So 1.245. Well done. Okay, terrific. So if you notice, it runs through the hypotheses for you. It picks your brain on, hey, the null, remember, is it fits the distribution. The alternative is it does not. HO is always the claim. The critical chi-square value, don't forget where that comes from, critical chi-square. Well, critical chi-square we could get from JMP as well, don't forget. In our add-ins menu, in our statistical calculators, where is it? Sorry, it might be in teaching module. Sorry, there it is, distribution calculator. So we've used this many times. Chi-square, I have a probability and I want to input a value. Remember, the degrees of freedom was 2. All right, and then this alpha region was, I believe, 5%. So let me put 0.05 in there. So I got a lot of people in the hallway talking and stuff right now, so it's really difficulty to work when it's not so quiet around here. But so the right tail probability is 5%, and you could say 5.9915. And if I go back here, getting the critical value of 5.991. So you could get these critical values from the chi-square table that's in the table section, or you could, don't forget, use your calculator and JMP. All right, so I hope this helps you out. This data is in fact uniform.